he cannot join a sorority. So they are, that two events are mutually exclusive. Does that make sense?
Yeah.
Okay. Pretty much you have to ask yourself, is the first event, event A, can event A occur with event B? If event A can occur with event B, then they are not mutually exclusive. Meaning that they can occur at the same time. They are not mutually exclusive. If the two cannot occur at the same time, meaning if it's a man and he cannot be a sorority, then they are mutually exclusive.
Okay.
Okay.
Can you give me an example of the independent one? Because there was never one with independent.
But they give you, let's move to the next one, after the next one, and then see if it's a little bit better in terms of independent versus dependent. Yeah.
Okay.
Give me one.
I have a question.
Yes.
For problem number 7, can you just explain again about like add in 4 over 30 then minus 3 over 30, if you don't mind?
So again, basically, again, the 19, this is how many female I have, right? The total female, that's 19 over 30. And the 4 over 30 is the age group between, again, this is the 4 I'm using, the age group of 48 over 50, 48 to 53, right? I have 4 people, agree?
Yes.
So again, and then why do I minus 3? Because the 3 is the female who is also in that age group, right? This is the 3 that I subtract right here, because those are the 3 female who is in this age group of 48 to 53.
Okay.
And then again, you just add this to give you 23. 23 minus 3, you have 20. And then you just divide.
Okay. Thank you.
All right. Now, that is the, again, one thing is the question that someone just brought up about, you know, event A, event B, are they mutually exclusive, or are they independent? That is just try to, I don't believe it's in your quiz. I don't believe it's in your exam, in your test. It's just try to make you think, kind of critical thinking in terms of how does the two item be mutually exclusive, or how does the two item be dependent or independent in terms of that. So again, it's just for you to kind of think in terms of, rather than work in the problem, rather than plug in the number and find, just think in terms of does the two events are dependent or independent or mutually exclusive in that way. But let's take a look at this next item that we have on our list, which is, if you read this thing here, same thing go, we have, again, we select one person, we select one item, right? And again, looking at this thing here, if you claim through, or if you read this number 8, they ask you find the property of that person is in the age group of 42 to 47, given that that person is a female, which is, again, as you can see, this word is our other key term that we have, which is, again, given, right? So what is the word given mean? Meaning, again, reminder, given is a conditional probability. So conditional probability, reminder, I told you guys, conditional probability, the first thing we need to ask ourselves is, what is our new total? We are no longer work with this 30. We will no longer take everyone in my class, right? This class, I have 30 students, right? I have male, female, and so on and so forth. Now they ask you, what is the probability? Find the probability that person is in the age group of 42 to 47, given that person is a female. Reminder that I told you guys that we no longer use 30 as my total. This is what we need to do, is we need to ask ourselves, what is after the word given? Which is, in this case, everybody see that in this case, let me change in color. Do you agree that in this case, this is what after the word given is the female portion, right? So again, whatever after the word given, that is the first thing that you want to extract out, right? So looking at this thing here, everybody see that I have 19. That is my new total. I will not work with the 30, right? I work with just the 19. Now, out of this 19, how many of them fit the first description, which is how many of them in the age group of 42 to 47, which is, do you agree that we have one? We have just one person who is in the age group of 42 to 47, given that person is a female, which is, in this case, this is all we have is we have 1 over 19, right? Which is, again, we are not compared to the 30 people left. There are something happened, which is, again, we want to pick a person who is in this age group, given that all the female is the one that we taken out, right? So again, everybody see that in this case, we have 1 over 19 and not 1 over 30 or anything like that, okay? And again, as you look at 9 and 10, if you look at 9 and 10, it's all the same idea in the sense that if you look at it, it's all the word given, right? All of this thing all deal with the word given. So looking at this thing here for number 9, we have, again, find the probability if a person is a male, given he is in the age group of 24 to 29. So given this thing here, or given this problem, right? Looking at this problem here, let me ask you guys, what is my new total? Who am I extracting out? Am I extracting out a male, or am I extracting out a 24 to 29?
A male?
Not
24, 29.
24, 29.
24 to 29, right? The first condition, the first thing have to met, the first thing that you want to make sure is that person have to be in the age group of 24 to 29. Okay, again, the male, you are not guaranteed that that male is in that age group, right? So again, the first thing is your total here is, the total is 5. We only have 5 people in that age group of 24 to 29. And out of that 5 people, how many of them are male? Okay, so pay attention that anything after the word given, that is your new total question. So everybody see whoever say extract the male, hopefully you guys see that, again, is what follow the given portion, right? We want to pick a male, but that male have to be in this age group, have to guarantee to be in this age group, okay? So again, that's what we have, which is, again, looking at this thing here, it will be 40%, 0.4, right? And again, same thing go here now, number 10. They write it a little bit different, but you have to be careful, or you have to see that, again, everybody see that given that person is a male. So that is what we need to extract out first, right? Given, right? Given that person is a male, which is, again, looking at this thing here, now I no longer, or I'm not looking at this age group, right? I'm looking at which one? I'm looking at the male, right? I'm looking at all the male, which is, again, looking at this thing here, my new total, my new denominator. Everybody say that my new total, my new denominator is 11, which is out of that 11, how many of them are in the age group of 36 to 41, which, oh my God. I do it wrong again, ladies and gentlemen. It's supposed to be 1 over 11, guys. It's 1 over 11, not 1 over 4. I type it wrong also. Is probability of 36 over 41 divided by the male. Okay, I typed this thing wrong, so my answer is wrong for this one. It's supposed to be 1 over 11, and 1 over 11 probably less than 0.1, so probably
0.09.
Yeah, 0.09 something. So
Yes,
again, it's 1 over 11, not 1 over 4. Sorry about my typo. So question with this given the conditional probability here. 0.091, okay. All right, any question with this conditional probability? So now this is where the independent and dependent come in, Okay, and again, for this one here, look at this item here. First of all, do you agree that, do you recognize that, first of all, we are selecting two people. We are selecting multiple item here, right? B, or this thing here, they ask you this, which is, again, if two people are selected at random, if two people are selected at random, what is the probability of you select a male? And then, again, this and right here is you select a male first, and then you go back and select a female. Everybody see that this and the previous and last time I told you that the last time, the and in the last time is and also, right? I picked this and also that person had to be this. Right? This one here, as you can see, there is no way that I can pick one person and this person is a male and also a female, right? There is no way, right? So again, looking at this thing here, I select two people. And again, what is the probability of me select a male and then I go back, select a female without replacement? What does it mean without replacement? Well, without replacement meaning you take one person out. You do not put that person back, right? So again, without replacement also, I did not cover this last time, is without replacement also is dependent. Meaning again, I select the first person, which is looking at this thing here. I go in to this group, I select the first person. What is the probability of that person is a male, and then the second person is a female? Do you agree that I go in the first time, I select one person, and this person is a female, is I have 11 male, the probability of male is 11 over 30, right? And again, I assume that I got the male. I got one male. I say, go outside. Now I go back. Do you agree that I go back the second time and I select this second person, and this second person is a female, which is now, do you agree that I have 19 female, but no longer out of 30? Why is no longer out of 30? Because I select one male and I tell that male person, go outside the room. Now, in this room, do you agree that I do not replace him back, meaning I only have 29 students left? Which is, everybody see that the second probability is pretty much the probability of female given one male is gone, right? Which is the conditional probability. But again, in this case, everybody see that because the probability changes, because something affect the second one, that's why they are dependent on one another. Okay, last time I did not give you this type of example, and I just, we assume something in terms of that, and you say, oh, how can we assume that it's dependent or independent? But again, that's what we have here is, given this example here, if we do not replace them back, meaning the second probability got affected by the first one. It's changed somehow. And because it's changed, they are dependent. They are not independent, right? No for independent, okay? So again, once you have this thing here, all we do is multiply straight across, which is 11 times 19, 30 times 29. And again, you just have this to give me 0.240, okay? And again, the other one that you see, which is, again, looking at this thing here, if you look at this item here, same idea, go, right? You look at this item and you say, well, I see this word and again, like I mentioned, because we select multiple times, we select multiple people, therefore we have to multiply, okay? Those are your key concepts here, which is looking at this thing here, they ask you find the property of select a male first, and then a person, you go back and select a person in the age group of 30 to 35 with replacement. What does that mean? With replacement? With replacement meaning I select one person, I wrote it down, I put him back, I say go back to your seat, and I select a second person, but that person can also be accounted for. Okay, so looking at this thing here, because of we replace it back, everybody see that the first time I pick, I have 11 male, same idea, same male, right? I have 11 male out of 30. But because, and again, I assume that I have him, now I go back the second time, I have 7 people in the age group of 35 to 30 to 35, which is I have 7 over 30. Why is over 30? Everybody see that this male, I pick him and I put him back, which is I do not, which is the total is the same. I still have 30 students, which is in this case, everybody see that if you replace him back, if you replace your item back, if you replace that person back, it will be independent because every time you pick it and if you replace it back, the probability is the same, right? So one thing is if you saw that the probability is different, then they are dependent, they are not independent. If you see that the probability is the same, or in terms of this thing here, the denominator is the same, then they are independent. Everybody see that if I pick 10 people and I keep on replacing back, everybody see that if I pick 10 people, that the probability is the same, right? If I say I want to pick 10 people and I want to pick the probability of 10 of them and 10 of them are male, which is the first person I pick is a male, second person is a male. But if I replace them back, I still have 11 over 30, 11 over 30, 11 over 30 every single time. Everybody see that? So in that case, which is now, because I replace it back, they are independent. They do not affect each other. Okay, which is if they don't affect each other, which is again, same thing, multiplication, you just top, bottom, bottom, and then you divide. Okay, so question between number 1 versus number 2, how does number 1 not independent, meaning dependent? How does number 2 is independent?
No, I have a question. Can you just go over it just one more time? Because you said if they don't affect each other?
If they don't affect each other, then they are independent. They are independent from each other. Meaning, think about one thing is, think about if you flip the coin and you roll the dice. You see the two events, you do 2 events. You flip the coin and you roll the dice. Does the coin affect the dice, or does the dice affect the coin? As you can see, that 2 events, they are independent because the 2 events does not affect each other.
Okay.
So, and
I'm
go
sorry.
ahead. Go ahead.
The independent. So it's dependent when you do you select the male and not put him back. That's when it's dependent. Yes. But when it's independent is when you take the person out and then put them back.
Yes.
Okay.
Yes. Pretty much because you put it back, you have the same probability all the time. Right. If you
Pardon me.
Go ahead.
Dr. Tran, would you say then that if an event is independent, then your denominator remains the same typically? Yes. And if it's okay. And if it's dependent, rather than the denominator would change.
Yes.
Thank you.
Yes. I don't have a deck of cards in my house. Well, but in the sense that one thing is the other keyword is the without replacement and with the replacement, right? Without replacement meaning you take it out, he's gone or she is gone, right? Meaning again, you have one less, right? And because you have one less, the probability will change it, right? If you put it back, which is in this case, if we put it back, then the probability is the same, right? And so again, with replacement is independent, without replacement is dependent or not independent. Okay, so looking at 3, you can see that again, they say find the probability of select both female, meaning the first person is a female and then the second person is a female too, right? So looking at this thing here, how do we find both of them are female, which is again, looking at this thing here, they did not see, you don't see the word and, but again, because they say both, meaning the first one is a female and then the second one is a female. But again, also you see that we are replace them back, right? Meaning I pick out one, I record her name, I put her back, and I pick out another one, right? Then yes, looking at this thing here, there are a chances that when you pick 2 female, when you place them back, they might be that 2 of them is the same person, right? 2 of them can be the same person because, you know, the chance that you pick her and come back and you pick her again can be the same person. But regardless, we just ask you, looking at this thing here, what would be the probability of a female and then another female, which is, do you agree that probability of female the first time, right? The first time I go in, I have 19 female out of 30. And now if I go in the second time, if I replace her back, do you agree that the second time I still have 19 out of 30, right? The probability of female multiplied to the probability of female, which is 19 out of 30 times 19 out of 30, which is, that's what I have. Everybody agree that in terms of 1, 2, and 3, again, 2 and 3, as you can see, they replace, or you replace them back, which is they are independent, right? And 1 and 4, we are not replace them back, right? Which is, again, looking at this thing here for number 4, looking at this item, do you agree that we're looking for the first person between the age group of 42 to 47 and the second person 42 to 47? And again, looking at this thing here, do you agree that the first person, I have 3 over 30? I got them. I know it's very small. It's only 10%, 0.1, right? But we assume, for this thing here, we assume that whatever you do, you are successfully got that person. Now you go back the second time, everybody see that I no longer have 3 people in this age group. Because I select one of them, that person is out. Now I only have 2 people in this age group. Now I no longer have 30 because I do not replace them back. I have only 29. Everybody see that right here, very clear that your probability changed, right? The second time you go in is not the same as the first time, 3 out of 30. Now you only have